Hello, everyone, and welcome back to the channel. In a microservice architecture, services constantly call each other. But what happens if one of your downstream services becomes slow or completely unresponsive? Your upstream services might keep trying to call it, consuming resources, time out, and eventually this can lead to a domino effect, bringing down your entire system. This terrifying scenario is precisely what the circuit breaker pattern is designed to prevent. In systems and interviews, discussing circuit breaker demonstrates a mature understanding of building resilient distributed systems. Today, we are diving into this crucial pattern. Okay, first, let's try to understand the problem. So imagine your user facing order service calls a payment service. For example, the payment service suddenly gets bogged down, perhaps due to a database issue or a network glitch. The order service keeps sending requests to the slow payment service. These requests start to pile up, consuming threads and connections in the order service connection pool. Soon, the order service own resources are exhausted, making it slow or unresponsive to other incoming user requests. This can then impact other services that call the order service, leading to a cascading failure that takes down your entire application, even though the original problem was just in one specific service. Traditional retry mechanism, if not combined with something smarter, can even make this problem worse by hammering the failing service even harder. The circuit breaker patterns offer a way to quickly fail and protect the system. Okay, what is circuit breaker? The circuit breaker is a design pattern used in distributed systems to prevent a failing service from causing cascading failures throughout the system. It acts like an ecri- electrical electrical circuit breaker in your house. When it detects that an operation is likely to fail, it trips immediately, blocking further calls to the failing component and returning an error or a fallback response to the caller. This stops requests from piling up and consuming resources on the calling service. Okay, so we now need to understand how it works. So a circuit breaker typically operates in three main states. First, we have a closed state. This is a normal operating state. Requests are allowed to be passed through the downstream service. The circuit breaker continuously monitors for failures. It keeps track the number of or yeah the number or rate of failures. We can say that. Number two, we have here open state. So in the open state, if the number of rate failures exceeds a predefined threshold within a specific time window, let's say like we have 10 failures in 1 minute, the circuit breaker trips and immediately switch to the open state. In this state, no new requests are allowed to pass through to the failing service. Instead, the circuit breaker immediately returns an error to the caller. It also starts a timeout period for like 30 seconds. This period allows the failing downstream service to recover without being hammered by more requests. Next, we have half open state. After a timeout period in the open state expires, the circuit breaker switch to the half open state. In this state, a limited number of test requests are allowed to pass through to the downstream service. If these test requests succeeded, it indicates that downstream service has likely recovered. The circuit breaker then switch back to the closed state, allowing all requests to pass through again. If the test requests fail, it indicates the downstream service is still unhealthy. And basically, I would say that circuit breaker immediately switch back to open state for another timeout period, and it might be longer. This state machine allows the system to quickly react to failure, protect itself, and then intelligently attempt recovery. Okay, why it is that important? The circuit breaker pattern is crucial for building resilient distributed systems for several reasons. Number one, prevents cascading failures. As we said before, its primary purpose, it stops an issue in one service from spreading and taking down the entire application. Number two, improved resilience and stability. It allows the system to degrade gracefully during partial outage rather than completely crashing. Number three, faster failure detection and response. By immediately failing fast when a dependency is unhealthy, it prevents clients from waiting for timeouts and frees up their resources. Number four, graceful recovery. The half open state allows a failing service to recover without being overwhelmed by a sudden flood of requests. Number five, enhanced user experience. By avoiding full system outage, users experience fewer errors and more consistent performance even during underlying issues. Number six, which is lastly, I would talk about something interview focused. Basically, I would say demonstrates a partial understanding of building fault tolerance, self-healing microservices. That will benefit you from knowing a circuit breakers. You will understand what is a fault tolerant. You will understand what is a self-healing microservices system should be or should look like. Okay, there are some considerations and also some interview discussions that we need to talk about. So when discussing circuit breakers in an interview, you need to remember some points. First, metrics and thresholds. You need to understand how do you define a failure. Basically, timeouts, HTTP5 errors, maybe a specific expectations. And also you need to know what are your thresholds for opening the circuit. Also, you need to talk about fallback mechanisms, like what happened when the circuit is open. Do you return a default value, an empty response, or an error? Also, you need to talk about monitoring and alert. Basically, you need a robust monitoring to track circuit breaker states and alert operators when circuit open or are flapping between status. Uh, yeah, states, not status. I would say also like in terms of the libraries, like many languages have excellent libraries. I would say something like Resilience for J, I guess. It's a great one. And in terms of integration, I would say often combined with retries only if you expect succeeds. Yeah. Yeah, that's it for this video, and see you in the future.